Where else are we seeing these kinetic energy systems being used?
Yeah, so obviously data centers, but if we look at the power grid that's feeding the data centers, power grids are actually using this to stabilize the power themselves. You can also imagine wind turbines, right? When the wind is not blowing steadily or the wind has a lot of variabilities in it, these flywheels are going to condition the power output from a wind turbine to be something a little more constant. But here's an interesting thing. This is where it gets really interesting, is in powering vehicles. Now you may say, well, that's a bit of a stretch. Actually, this is where flywheel batteries started. In 1953 in Switzerland, a company made something called a gyro bus. And this bus was a tram that ran 6 kilometers in between two Swiss towns, I guess delivering cheese or chocolate or cuckoo clock, something like that. But anyway, this gyro bus would plug into power. It would spin the gyros up, and there was enough kinetic energy in there for this tram to run 6 kilometers in between these two towns. In the Netherlands, they've actually made a hybrid vehicle that is a hybrid between kinetic batteries and a gas-powered engine. So there's this hybrid vehicle that's operating on this. One of the weird things, though, on a hybrid car, if you have one flywheel, you have these gyroscopic effects, which if your car is, like, let's say driving on a slope, it could actually flip the car. And so these flywheels have to be gimbaled so that as the car goes uphill, downhill, turns corners, that flywheel is allowed to gimbal itself so that it doesn't actually start moving the cars. This is so powerful. The USS Gerald Ford, one of the newest super carriers in the US Navy, is actually using flywheels to launch aircrafts off the catapults. Typically that through history has been done with steam. That is now on the latest aircraft carriers being done with flywheel technology.
You know, the other thing that you were reminding me of, Mark, through this, you brought up automotives. We've been using ceramics for their high-speed properties, or their ability to withstand lots of pressure at high speed for turbos. And as turbos get more important, forcing more air into a cylinder to create a bigger explosion when you need it, we've seen a lot of research that's gone into ceramics. And I wonder how much these two approaches are feeding off of each other. The things that we need to make cars go faster, which I care a lot about, and the things we need to do to make power smooth, which I also care a lot about.
You hit on something I think is important, and that's the bleed over from some of these technologies, whether it is superconductive mag levitating bearings. There's amazing bleed over to that. An interesting one, though, let me throw this out there, is in satellites. So satellites have solar power, so they actually do have quite a bit of electrical power. But of course, satellites have this bad habit of moving on to the other side of planets where there isn't a sun to keep the power going. But if you have a flywheel inside of your satellite that is powered by that, then as you go through the dark side of the moon or other Pink Floyd albums, you're able to take that ride over energy from the flywheel to keep the satellite powered without having the typical chemical batteries in there. By the way, side benefit on a satellite, that gyroscopic precession effect that we talked about that might flip your car is also wicked cool for stabilizing satellites. So you kind of get some more bleed over engineering into